Hi everyone. A warm welcome to today's webinar. Is your legacy system a hidden risk? De-risk with AI-powered intelligence. Our discussion today explores how AI-driven agents are transforming the modernization of legacy systems, making the process faster, safer, and far more reliable. I'm Rohina Chawla, your host for today's session. It's a pleasure to have you all with us for what promises to be a very insightful discussion. A few quick notes before we begin. We will be sharing a recording of the session so you can revisit or share it ahead later. For the best experience, we recommend using headphones. Lastly, if you have any questions during the session, please post them in the Q&A window. We'll take them up towards the end. Giving you a bit of context of the session, legacy systems continue to run critical business operations. But as technology and business needs evolve, modernization has become essential to stay efficient, secure, and future ready. Today's session will explore how AI-driven automation can make modernization more intelligent and reliable. Our experts will cover the key challenges with traditional modernization approaches, how Amantya's AI agents accelerate transformation with quality and reliability, a demo of Amantya's AI agent suite in action. We'll close with a short Q&A session, so please keep them posting. Please, keep posting your questions. Leading today's session are two of Amantya's senior leaders who have been instrumental in developing our AI modernization framework. I will quickly introduce them before we begin the session. First, we have Gaurav Sharma, Senior VP Engineering at Amantya. Gaurav leads Amantya's AI practice and has been closely involved in developing our agentic AI suite. With over 2 decades of experience in telecom and enterprise systems, he brings a unique blend of engineering depth and practical insight into AI-led modernization. Joining him is Saurabh Gupta, AVP Technology at Amantya. Saurabh brings over 20 years of experience in transforming complex enterprise systems across sectors. At Amantya, he drives initiatives that align AI capabilities with real-world modernization goals, ensuring every transformation is measurable, secure, and scalable. With that, let's get started. Gaurav, over to you.
Yeah, thanks, Rohina. Good morning, good afternoon, and good evening to all the people who have joined the meeting today. Just to set the context in here, as Rohina mentioned, right? So we'll be talking about why there is a need or why there is a requirement for bringing in AI, or how does it help to actually build or help in migrating code from legacy systems to modern systems. How can we leverage AI for doing that, right? What are the kind of advantages that it has? What kind of challenges or pains that we've seen or witnessed with the manual migration, right? And how does AI address them? So we'll be talking about all those things. Just to add a little bit more color onto this, we also thought that probably we'll also talk a little bit about why Amantya as an organization kind of fits very well into building such sort of solution. And why is it that the solution that we have built that checks all the right boxes, right? Again, it's something which is in the works, but still we've done a lot of investigation and a lot of code built into this. This is again a working solution. We have used this in migrating some of the customer projects plus some of the internal source code bases as well, right? So to take you forward on this, first of all, a little bit about Amantya. We are close to around 800 plus engineers, right? We bring in a lot of expertise in both digital as well as telecom domain, right? And we have offices spread across different geographies, right? We've been lucky in the sense that we have received various awards in various domains as well. Specifically on the AI side, we have been doing a lot of work for the past few years now, right? And this is work is kind of spread across again different domains, right? We do a lot of strategical consulting on this for our customers, right? Guiding them or advising them into how to kind of bring AI into their existing systems. We do a lot of data engineering, analytics work. Now, AI is such a fast-moving or fast-paced domain, right? That every day there's something new happening. So, at least the good thing is that we have uh, been keeping pace with what has been happening in this particular field, right? And so, some of the more contemporary or latest techniques or latest things that have been happening in this space, we have worked on these, right? So agentic AIs, we built systems around that. We've done a lot of work on open source on-prem AI solutions as well, right? And this partly comes from since a big part of our organization is developing telecom software, right? And a lot of operators or a lot of OEMs in this space typically are very sensitive about the data that they have, right? So they continuously look for on-prem solutions. So that's one area wherein we've had a lot of experience, a lot of exposure, right? And for me, personally speaking, the more you explore a particular technology, or the more experience you gain in a particular technology, the better you understand it, right? So it isn't a very rosy picture to begin with, but then as you learn the technology better, you understand the pitfalls, you understand how to circumvent things, you understand how to solve certain issues, right? So it's all about gaining those experience, and we've been kind of lucky in that sense. Specifically in code migration, as I was saying earlier as well, we've been very lucky to actually evolve this pipeline of various agents which actually can take a piece of code and turn it around. I'll talk a little bit more about that a little bit later. But yeah, that's again one area. Autonomous networks or observability and automation. As I mentioned, we do a lot of work on the networks side, and these two things are the key applications on the AI side, right? So, autonomous networks, how do you actually get the required KPIs or the required metrics from the network, and how do you train AI agents to actually understand what is happening in the network? How do they kind of control or predict the future? And based on that, if they need to reorchestrate or replan or reconfigure certain things. So that is an area as well that we've had a lot of exposure to. Uh, we have a separate vertical, digital, as well, that does a lot of development on cloud, DevOps, right, data analytics. And herein as well, some of the latest techniques on the data analytics, lake houses, those kind of things. And how do you actually use GPUs, or how do you use AI related technologies to actually come up with faster analytics with some more deeper insights. That's again one area where we've had very good exposure to. Telecom expertise, of course, we do build mobile network cores. But what we have also done is that we build a lot, since we build a lot of testing solutions, we've again actually gone ahead and built very interesting features on our test tools around AI, right? So how can AI actually help in better testing, right? So we've got AI-powered test automation. We use AI-based log and pcap analysis, those kind of things, right? Now, the reason I've spent some more time on this particular slide talking about our experience or our expertise in some of these areas is to just set the context in here that since this is something that we've gained a lot of experience on in the last few years. Obviously, the logical step for us was to actually see how do we use all the experience and the knowledge and the expertise that we have gained into building the migration pipeline, because being a software organization, we ourselves at times have legacy code, plus a lot of our customers face this challenge of migration in the legacy code. So based on all these different things that we've learned over the last few years, we went ahead and built this particular thing. Now, moving to the next slide. Yeah. Now, typically, what is the legacy system dilemma right now? If you look at the way technology has been moving, especially in the last 1.5 or 2 decades, the speed is amazing, right? So you've moved very fast, very swiftly from, say, monolithic basic systems to microservices, DevOps, on the cloud, those kind of things. You've changed languages, more interesting frameworks have come up, right, and so on, which means that a lot of code that we have today running, that has become old quite soon, in the sense that say we've seen where an implementation was done just a few years back, and now because of the framework changes, certain vulnerabilities, or certain gaps, or maybe end of support for certain associated libraries, it's just very difficult to continue with that piece of code or some of the associated software with it. But for an organization, the challenge is that I mean, there's a simple quote that if it isn't broken, don't mend it, right? But here, one is forced to actually change or upgrade things because the support has ceased, right? Or you're not no longer compliant to, say, certain security standards, or you can't keep on using the older code, right? The other problem with this is that in case, what happens if there is a bug that suddenly crops up? Uh, it's very difficult to actually fix bugs in older pieces of code, right? You don't find developers with that legacy knowledge, even on the information on the net which is available, that is scarce, right? So it's actually very difficult. And then testing of these fixes that one has done, that's another problem, right? Uh, Another problem that we've seen in our experience is that people don't realize at times that some of the hidden dependencies or some of the libraries that they may be using, right? So they may have certain errors, or certain issues, right? That may be causing a lot of bad user experience into their systems, right? This may be not only this may show in the user features, or functionality, but even if you have to scale up systems, right? Traditional systems being mostly at times monolithic, but since a product may have become very popular, it's not easy even to scale those systems, right? So that's another issue that comes up, right? The very essential difference that I would like to make in here, because when we talk about migration, there are two things associated to it. One is the architectural changes, and the other is the software changes associated with it, right? Let me give you a very small example. Say, I am using a particular library or a particular framework that gives me one sort of interface only, right? It may be a library call, or it may be a JSON RPC or something on those lines, right? Now, what if the newer framework or the newer system that I need to migrate to does not provide me that interface, right? Which also means that essentially what I'll have to do is that there are certain architectural improvements or changes that need to be also looked into, right? So migration is typically not only changing source code to a new framework or using just some keywords. What it also entails are architectural changes into this, right? So changing the architecture from a legacy system to a newer one, that is also that presents its own set of challenges, right? So we've looked into those aspects as well. Now, just to give you a comparative view between traditional migration, the challenges in it, I mean, you can obviously go ahead and use a general AI tool, right? So maybe you can just open ChatGPT, and try to migrate code, right? But then there are certain limitations or constraints with that. Let me talk a little bit more on this particular thing as well. Traditional migration, as I mentioned, manual parsing of legacy logic dependencies, especially with teams that may not be aware of legacy code, or people who have originally written these lines of code may not be available with you anymore. Teams may have been moved or they may have moved on. So it's always an issue, right? And especially regressions do creep in when you change these legacy things, right? The other thing being that people, when they code with different styles, right? So it's not easy for somebody new to come in, understand what has been written, say, 10 years ago, right? And then change it directly into something very modern, right? Uh, if you look at these general AI tools which are available today, which are good, by the way, say you have very good coding agents, but the problem with singularly using those tools or directly using those tools is that they have a very limited architectural awareness, right? So, say if you're using a particular, say, public LLM or whatever that you want to use, how do you actually provide a wider context to that particular model so that it is aware of first the architectural changes that it needs to do, and then the coding changes that it needs to do, right? So it's a context problem, right? The other thing being that legacy codes at time is kind of huge, right? So how do you actually build that knowledge? How do you build that view for the LLM that this is how my code is structured, right? Because essentially, if the LLM does not understand your code well, the suggestions or the changes that it'll do, they're never going to work, right? It'll actually break everything, right? And you'll be kind of left midway. So it's actually difficult for me to come up with a repo and use it as such with a LLM, right? The another aspect to this, and we've seen this with a lot of our customers, is the data privacy, right? Nobody likes to share code, right? No organization would want to dilute its IPRs or send this information to the cloud, right? So looking at all these challenges plus couple of few things, what we have learned from our experience, right? We ourselves do a lot of software programming. We do a lot of we've been involved in migrating a lot of projects. So what we thought was that how do we best actually address this particular issue, right? So that is how we came up with this particular platform. And of course, we've used a lot of contemporary techniques in AI to do this, right? And again, what we've essentially tried to do in here is that learn, understand how migrations are effectively and successfully done, break them down into very small steps, and introduce each of those steps into our migration pipeline, right? And that's the reason why the pipeline, and we'll show you the details of the pipeline a little bit later. You should be able to see a number of steps that you can actually relate to, right? The whole idea is that if there is a good team of engineers, how would they migrate code, right? So we've taken all those best practices and implemented those through our agentic framework, right? So we have all these different phases. We do integrate with a lot of tools as well to ensure that the code that we have generated or migrated to that conforms to a particular standard, right? Of course, migration, especially for large repos, is a time-consuming process. You would need a solution which is scalable. So we on the platform that we have that allows you to do that, right? It exposes automated APIs as well. So in case if you want to integrate this platform to one of your existing solutions or one of your existing frameworks, you can do that. In case if you want to use one particular agent or one particular piece from this platform, you can do that. So it's quite modular in that sense. And plus, the best part is that you can run this all on prem, right? Which means that you don't need to share data to the cloud. It's quite flexible in the sense that the choice of LLM, the choice of models that you want, you can change them as per your liking. So it isn't as if it gets hard coded or plugged in into the platform, right? Of course, there are suggestions from our side on what to use, how to use, right? But then we are always open to actually listen to ideas, listen to feedback, and then accordingly work on that, right? So let me move to the next slide. That and what I'll do is, since now we'll be talking more about our modernization tool, I'll just hand over this to my colleague Saurabh, who will now take us further on this. Thank you.
Thank you, Gaurav. Hello, everyone. A very good afternoon to you. Um, the context, as Gaurav has set up about this code migration tool, I'll just expand it like how we started on that and what all we built on this. So we've been working with various clients, and so far we have done a lot of code migrations, and we have seen that the code migration does involve a lot of knowledge, prior knowledge, and then a lot of testing. And then there is no clean way to ensure that everything is taken care of. But if we put this thing into the pipeline, and which with the use of AI, we can definitely gain some confidence on what we are doing is going into the right way. And for that purpose itself, in addition to that, I guess there is a problem like when we are looking at the legacy code, we don't have the team around most of the times because people who have developed that code probably they are not anymore with the organization. They have moved on. So getting the information about the code, figuring out what is the right library, how the code has to progress, and then ensuring that the code is still working the way after upgrades, the way it was working before, in terms of functional aspects. So to ensure all of that, we thought the use of, making the use of this AI based code migration tool. The steps are pretty much straightforward, which we do follow in our day-to-day migration projects also. This tool will read the code, after which, it basically take the code in as an input in form of zips or the repositories. It will do the initialization wherein it will create the complete snapshot of the code base. It will read the configurations and infra-specific information of that. It will initialize those repositories and look at the versions and what is the dependency catalog. It will try to make that. Um, then comes the most interesting part, which is the analysis and mapping, right? So basically, to figure out how what this code is, what is the dependency graph is, how this ASTs need to be prepared. Basically, it provides as an input to show or to make a graph of all the dependencies to be able to to be able to successfully identify like what is the dependency between the files, between the projects, and between the repositories. Thereafter, once we have the dependency graph built, we basically highlight. This AI code basically highlights the red flag zones where what is the simple ones to migrate, where it needs to take more cautious approach. So once we have this analysis and mapping done, thereafter the actual migration logic and transformation logic will start. Again, using the models we have in place, we have utilized those depending upon the languages and all in which the input code is. Accordingly, it starts the transformation. It basically identifies which transformation model to take care of. To take in consideration and move forward. This is the place where all the migration logic will be in place, which library needs to be replaced with which new version of the library. Again, the old libraries may be having some security vulnerabilities, and then it will identify also that the new library that we are using, if it is having the vulnerability or which is the one which does not have the vulnerability at present. It will try to pick that model. It will try to pick that library and accordingly do the migration for that. And once the migration is done, thereafter it is basically the feedback loop and validation to ensure that when it has completed the migration, is it doing the same activities? I mean, same functionality is retained or not, and all the logs while doing the migration, they are preserved. The test results are stored in the pipeline. I mean, all the tests will be run, and this will ensure that this migration is with the issues or not. Any if there is any need of a transformation, it will refine itself, and then there are I mean, based on the rules which are there, which we have coded. To figure out if there any transformation is required. It identifies with the failure and accordingly apply the rules to make it more workable with the migration. And the final step is the automation testing, wherein it will figure out the existing use cases which got migrated with the code, as well as the need of the new test cases, if at all it is required to create. It will create on the fly to ensure that the coverage is pretty much there. All the code that got migrated is pretty much covered with the test cases, and then it will publish the results as well. I mean, this whole pipeline seems very straightforward, but I guess this is when we are doing it manually, it is taking it takes months to do these kind of activities. But with the use of the available AI tools, this whole pipeline can run seamlessly. Um, Depending upon where the user inputs are required, at least while executing the code, it shows on what it is doing. The complete logs are printed, so that I mean, user is aware of what it is running, what is the that particular step is producing. Um, yeah. So again, if there are any step a human intervention is required, we have built hooks in between, wherein the uh, uh, I mean, user can add the inputs, and accordingly the course correction can be done. So this is on the very high level, the high level flow of this particular tool that we have created. Right. Gaurav, would you like to take? Uh, yeah.
Yeah, I'll take this particular slide. So, as I mentioned earlier as well, right? If you look at the pipeline that Saurabh just spoke about, right? There are certain very key aspects to this, right? The various phases or the various steps that Saurabh just mentioned, right? There are agent or agents running on each of those steps, right? So say, for example, there is a agent which is responsible for code reviews, right? Of course, there is a communication between the reviewing agent and the writing agent so that the generated code is correctly reviewed. Any comments or any errors that the reviewing agent finds out, right, those are correctly addressed, right? Similarly, there are agents for writing unit test cases. There are agents for actually creating those dependency graphs. There are agents to actually understand what is happening in the code itself, right? So it follows a purely agentic framework. The advantage that we get is what I mentioned earlier as well, the solution being modular as well as extensible, right? So it's easy for us to actually take out a agent, put on a different agent, right? We've also put in interjection points. So say, for example, if I need to migrate a piece of legacy code, right? I'll take a very simple example, right? Now there is a planning agent that comes into action first, and it creates a high level plan that, okay, I've created these dependency graphs, I've created this contextual map so that I understand the code architecture better, right? And this is how I plan to do this, right? And as I mentioned earlier, there are for code migration at times it's not a simple code migration in that sense, but then it's a architectural migration as well, right? A lot of people tend to underestimate that aspect. So the plan that gets generated, the human intervention, what it can do is it can update or modify or edit that particular plan. Now, to give you a very simple example, it may so happen that in some of the modern frameworks that we have, uh, because of obvious reasons, a lot of communication has become more asynchronous, event driven, and those sort of things, right? Now, in case if there is still a need because of some reason that the organization wants to not take a particular approach, right, which may be recommended by the AI agent, the human can go and actually change or modify that particular plan, right? So that's just one small example of this, right? And as I mentioned, we do understand how a lot of AI models or AI work happens, right? So the parallelism that needs to be brought into this, right? So when I say parallelism, what I'm referring to, say, if there's a very large repo, I'll give you a very small example. One of the repos that we were working on that had thousands of Python files, right? Now, the migration in itself was something that would take some time, right? Now, how do you actually deploy this particular platform in such a way that you can take advantage of a distributed parallel framework using multiple GPUs, right? So that is also a very interesting aspect to this particular solution, right? Context, as I mentioned earlier, there are a lot of interesting things that we do so that the LLM or the models that we are using, they understand uh, the context or the code architecture quite well, right? Again, as I mentioned, these are private models, mostly in case if there's still a need for integrating with the public LLM, and it's a simple configuration, you can flip the switch. One of the agents in this whole pipeline is the security vulnerability FOSS, those kind of checking those kind of things. And in case if there is an anomaly, there is an error, or there is a some vulnerability that is detected, right? So the agent flags it, and then accordingly it can be modified, right? Uh, the other aspect is that, of course, this can obviously be a part of your CI/CD pipeline or any automated system that you may want to use. I'll give you a very small example because this is something people will ask that why do you need a migration platform connected with your CI/CD pipeline, right? Because you are not going to do migration each and every night or each and every build, right? Now, as I mentioned, the whole system is quite modular in that sense. Again, one of the agent, what it does is that for all the migrated pieces of code, or depending upon what the configuration, it starts writing unit test cases, right? Now, and this is an exposed functionality. Now, say now you want that every day the code that is being checked in, or maybe on a weekly basis, or whatever your cadence is, I need something that uh, writes unit test cases for functions where these test cases don't exist, right? So what you can essentially do is just call a particular API or interact with a particular agent of ours to actually utilize that set of capability, right? What we've also done is that at times what we see is that uh, to understand the code better, especially with external databases or external servers, right? Uh, there are times when the data isn't that well exposed to us and legacy data is present. Now, what if the third party code has changed, right? Or those things are not clearly visible to you, right? So what you can also do is build the MCP client within our agent, which can then access external information and provide the guidance to our code writer agent to actually, this is how you go ahead and rewrite some of these test cases, right? So that's also a unique feature to this. Feedback, manual intervention, as I mentioned, that's again a key aspect to this. We always believe that there has to be human in the loop. There has to be, at the end of the day, a human who's actually validating or verifying what is happening within the pipeline, right? And we've tried to actually break a very large task into very small steps, which are traceable, which are clear, which can be observed. And in case if there is anything that gets flagged or if there's anything that looks sideways, right, the human act can then go ahead and do the necessary changes. So from an explainability point of view, right, we do provide all the required information possible for the humans to or the users to actually understand what is happening behind the scenes, right? So it's just quite open or white box in that sense, right? So that's again something that we learned from our experience over the years using AI in various tasks. This may be simple code writing. This may be trying to understand some of the design details, right? Those kind of things. So that's also a key aspect to this, right? I think there's another slide to this. Yeah. So so then the next obvious question or obvious thing that we would want to talk about is the impact, or how do you actually get benefit out of this particular thing. And again, these are numbers that we've seen with our customers or with our sample business cases that we've kind of been part of, right? Accelerated deliveries, obviously, I mean, uh, a number of times our customers, uh, I mean, the challenge that they face is for migrating code. It's difficult to actually get hold of team members, right? But with this particular thing, before you can even put a team together, right, the code gets migrated, right? So depending upon again the complexity of the project, the older technology vis-a-vis the newer framework that one would want to use, right? So the delivery timelines, they get kind of squeezed in, which also means that you get more time to actually test the implementation, right? Because we've also seen migrating, especially legacy codes, and it's just a practical problem everybody has seen. I mean, the code gets migrated with some delay, then there's little time left for testing it, and then there's a cutover date that cannot be changed, right? And then you start getting errors once things are in the field, right? So obviously, when I see this word accelerated delivery, what it means for me at least is you get additional opportunity to test your code, right? So that's a very big advantage with this, right? Optimized costs, obviously, since most of the work that is done by the AI pipeline, right? So costs do get drastically reduced, right? There's reduced manual effort involved. What that also means is that now that manual effort can go into building more features, right? So say, for example, because again, this is a pain that everybody knows for an organization, right? You have limited manpower or limited bandwidth available. Either you spend that manpower, that bandwidth into modernizing legacy code, which, by the way, may not give you a lot of new user functions or new user features, right? So the obvious advantage here is that, okay, you go ahead, you use this particular platform and migrate the code. But it means that now the bandwidth that is saved, that can be used by your teams to actually build more interesting features, right? So it's a win-win situation from whichever angle you may want to see it, right? Of course, since we have agents that ensure this thing that the upgrades do comply to certain standards or are integrated with external tools, static analyzers, so, vulnerability analyzers, and so on. So you can do those as well, right? And plus, the obvious advantage that you are now running a more future-ready architecture, which is more scalable, which is more contemporary, which is more in line with what is happening today, right? Obviously, that gives you a more sense of confidence, reassurance, and then those sort of things, right? So that's a quick summary of the advantages of this particular tool. Of course, and as I mentioned earlier, we have been using this tool with some of our customers as well, right? So one was, again, one of the real estate data providers in UK, where we have migrated some of their legacy code, right? There's a telecom operator as well, right, where they had, again, a very old legacy pieces of Python, robo frameworks, those kind of things, right? And the best part is that this is kind of language agnostic, right? In the sense, you may want to migrate from a very old .NET version, you may want to migrate from an old Python version, right? So it's quite agnostic in that sense. So it's not limited to one particular framework, right? So again, these are some of the success stories that we've had. And internally as well, we have been using and improving on this particular tool. So I think we can jump on to the next section, Rohina. I'm a little bit watchful of the time as well.
We'll just begin with the demo. Just give us a couple of seconds.
Welcome to the demonstration of the Amantya code migration platform. In this video, we will walk you through straightforward with the process of migrating your code using the advanced AI-powered system. Let's begin at the login screen, where you will need to sign in to access the platform. Simply enter your register email address and password in the designated fields. Once you entered your credentials, click in the Sign In button to proceed to the main interface. After successfully logging, you will be presented with the platform interface, which includes options for the code migration. The platform makes it easy to upload your code file for migration. You can select multiple files or entire directory that want to you migrate. Our system supports various file formats and the programming languages that ensure compatibility with your existing code base. With your file selected, simply upload them to the platform. A progress bar will indicate the status of your upload. Once all the files are successfully uploaded, you are ready to initiate the migration process. Click to the Start Migration to begin to the transformation of your code. As the migration proceeds, the platform showcases a series of the specialized AI agents, each responsible for the critical steps in the migration pipeline. As the migration process is now complete, you can see the successful completion status on your screen. Your code has been transformed and optimized using the advanced AI algorithms ready for implementations in your target environment. This automated process saves countless hours of manual migration work while ensuring the accuracy and maintaining the code integrity.
Right, I think that was the demo. Thank you, Gaurav and Saurabh, for the insightful session. It's really interesting and exciting to see how AI can fundamentally change the way enterprises modernize the legacy systems. So we'll open the floor to questions now. Please continue posting them in the Q&A window. We'll take as many as we can in the time we have left. Okay, I see there are a few questions already queued up. Let me begin with the first one. Give me a moment. Can the agents learn from past projects to get better over time? Gaurav, would you like to take that?
Yeah, definitely, definitely. Okay, so this is a very relevant or pertinent question, right? And the way I see it, this is not only kind of relevant for migration, but it's kind of applicable for a lot of AI related work that we do, right? And this is something that the industry has come up with several solutions for this thing, right? I'll give you a very simple example in here and again, right? You would have heard about the concept of rules or concept of guidelines or concept of plans with our agents, right? So essentially, we also follow a very similar technique, or we also follow a very similar methodology in here. Whatever the agent has learned from the previous runs, right? And of course, the users can modify that learning. What we keep on adding on to our rule based migration are custom steps or custom rules or custom orders to the agent to follow, wherein if there's a specific way we want the migration to happen, or what we've learned from our previous migration that probably this is how this worked better, right? We can explicitly add those rules or those orders or those guidelines to our rule engine, and the agents are fed those steps so that the agents are cognizant of the fact that these are the kind of things that I need to follow. And it's a growing set of rules, right? You can do it manually. The agents also do it based on the feedback that you kind of provided, right? And again, this is again got to do something with the methodology of migration, right? Again, I'll take a very simple example. Now, typically, say if I have to migrate a large project, right? What I do is that I typically don't do a big bang. I take, say, 200 files and then change the code and then start to compile it and then see what has happened, right? I take a very small subset of this. I try to migrate that first, compile that at first, so that I get a feel of what are the kind of challenges, how do or where I need to do those changes, right? So, as a practice, we also kind of advise to start small, to do this in steps, so that the rule engine becomes more efficient, right? And the rules are more clearly. So yes, the agents do learn from what has happened in the past. Next question, Rohina.
Yeah. Does the tool plug into existing CI/CD tools?
Yeah, I'll take that. Maybe next, sort of, you can take it. So yes, as I mentioned earlier, there are various steps, various phases in it. So you can go ahead and plug this. I mean, from my perspective, I mean, some of the areas where I find this tool can be integrated with CI/CD pipelines. As I mentioned, there are different agents in it, right? So you have a unit test agent, you have agents that do static analysis, you have agents that run vulnerability tools, CVT analysis, those kind of things. So you can definitely go ahead and independently plug them in.
Right. Um, how does one second. How does the system ensure nothing breaks after modernization?
Um, yeah, hi. I'll take this. So, as if when I was demonstrating the whole flow, the last step is the unit test, running the unit test cases. I guess that is one way to ensure that um, uh, the system after migration is working similar to how it was working earlier. And it has two steps. One is like converting the existing unit test cases into the new, with the migration, migrating the existing unit test cases, and similarly writing the new test cases for the migrated code. I mean, if there are any changes that are required, plus if there is any additional test case which is required for the code. So when you're running the unit test cases, if there are any failures in between, it will take care of that. It will analyze that, and then it will do the course correction, and eventually ensures that your all the unit test cases are running. I guess that is the way it ensures that your code would still be running.
The next question is, will the entire system, agent and model, run on premise? If yes, what's the hardware requirement?
Um, so yes, it is built to run on premise. The hardware requirement depends on how big the code it is, because basically, I mean, the number of tokens which will derive, and then the number of tokens will be driven from the size of code itself, right? So, I mean, we have tested it with the smaller LLMs, and then I mean, definitely, if the code size is a lot bigger, then we need to increase the hardware, the GPU capacity. So, ideal a small code may run on a 48 GB GPU, but I mean, if you have a big piece of code, then accordingly, the system size has to be increased.
Do you handle mainframe and mid-range technology? Gaurav?
Yeah, that's a interesting question, right? And probably I'll club it with the mixed tech stacks question as well. I just see above that, right? So yeah, look, the thing is, and I can understand. I mean, a lot of extreme legacy things, right? People would want to migrate and would want to see how does AI helping doing that. So it's perfectly very relevant question in here, right? Now, what we typically do is that we depend upon LLMs for uh, migrating, rewriting codes, right? And plus, of course, that is something which is augmented by uh, rules and some of the human inputs, right? Now, if we have a LLM, right, and of course, it's a LLM that understands the mainframe technology well, or it has been trained with those constructs, right? Definitely, the system is agnostic in that sense that any technology it can do that, right? Of course, there would be subtle things that we would need to add on to this in terms of rules, because some of these things, um, since at times we've seen for some of the rare technologies or for some of the areas where there isn't a lot of public information or tech stacks available on which the LLMs are trained, they struggle at times, right? Herein, what we typically can do is maybe augment this with the basis on the basis of adding a RAG pipeline, right, to actually further provide some more context to the LLMs, right? So again, possibly yes, this can be done, but yeah, the accuracy it'll kind of depend upon what model we are using, right? What's the size, how old that code is, what constructs it is using. And of course, in case if we come up with a better rule description for this, I'm sure we should be able to reach a sufficient level of accuracy where it makes perfect sense to actually use this particular platform, say to say 60% or 70% of the migration of the files, and the remaining 30%, 20% that can be done through humans.
Right. The next question is, how does agents and on-prem LLMs learn latest updates happening in the tech space?
Okay, so again, there are a couple of things. The models that we have, so we keep on upgrading those models, right? And again, you have newer models coming up every week, right? So that is something that we keep updated on, right? Apart from this, comes the ability wherein I mentioned, uh, wherein we kind of augment what goes into the migration process through our rules, right? So in case if, look, the thing is models get trained on whatever the public data is available, right? And the retraining process is a time consuming process, right? So we do keep our models updated, but we do also augment these things with our rules engine, right? So say, for example, there is a newer framework or there is a newer technique or there's a new language construct that has come for the latest Java or whatever tech stack you are using, right? But the LLMs are still not able to explicitly call that, right? So you can go ahead, update the rules or the plan file, right? Explicitly instructing the model to actually interpret it. Plus, you can also provide model additional context through the RAG pipelines that the newer construct in Java or whatever language you are using. This is the definition of this particular thing. This is how this gets implemented. And if you can actually target to use this particular construct or that particular structure. So you can obviously enrich or augment your LLM with the context, right? And that's exactly the reason why I said that whenever we do this migration, we don't go ahead and migrate 500 files in a single go, right? Essentially, the steps that we always advise is that take a small subset, run this pipeline on that, come up with a very good rules engine or come up with some good instructions, right? Additional instructions to augment the output and then kind of do the migration. So yes, the system is extensible in that sense. You can augment it always, right? And plus, of course, the models that I mentioned earlier as well. I mean, you're free to use any model that you would want, right? It just needs to support OpenAI APIs. In case if that's not possible, of course, we can put a small gateway as well to convert the API formats as well.
Is there any documentation agent will prepare after migration for future usage knowledge purpose? How is the tool, how this tool is secure as team upload whole repository code?
Okay, so yes, definitely. One of the last steps of the migration is generation of the updated code, right? So it does capture what has been updated right now. Second, on the security aspect to it, of course, everything is running on-prem. So it's as safe as your network. So if your network is safe, your code is safe, right?
For each step required in migration, are we using different LLMs for each steps based on the kind of task or the same LLM that we have trained specifically for that step?
Okay, so again, it's a configuration thing. We do have our recommendations based on what we have experienced, right? But in case if the customer has a particular demand, right, we can obviously, it's a modular extensible thing. I mean, for one of our customers, they wanted the code reviews to be done through a particular public LLM, wherein we just send very small snippets of code to it, right? So that is also workable in case if you want to use some other open source LLM running within your prem, right? So I may be using Llama. Somebody may want to review the code using a bigger DeepSeek model, right, or Kimi or whatever it is. So you can obviously configure the agent. I mean, the only thing being, as I mentioned earlier, it needs to support those APIs. We do provide support for OpenAI on a couple of other formats. In case if the model needs something else, probably we'll just have to put in a small gateway in that.
We're really running out of time,
Yeah.
so we'll take one last question.
Maybe Saurabh can take that.
Junit, am I pronouncing it correct?
JUnit.
Is one part of validation. Is there a way to make sure that upgraded system will run fine on deployment in containers?
Am I audible? Yeah. Okay. So, I mean, we did mention the last step is unit test cases. Again, there are two type of test cases that we generally do execute. So they both, I mean, the unit test cases are one and the integration test cases are the second one. So as part of the whole migration, if there are integration test cases, existing integration test cases, those can be migrated as well. And then, yes, I mean, we can configure it to generate the integration test cases at the end. And the integration test cases will ensure that, I mean, if the integration test cases are passing, means my application is running after the deployment as well. So we are also extending it to actually do the deployment at the end. So this is like one of the extensions that we are already working upon, that it will do the deployment of the code also and run the complete integration test cases. But yeah, I mean, as to facilitate that, at least the conversion of integration test cases are also done as part of JUnit or the unit test cases update.
Right. Thank you so much, Saurabh. Thank you, Gaurav. That brings us to the end of today's webinar. Thank you all for joining us. Most of the questions have been addressed. For any remaining ones, we'll follow up offline. Because of the time constraint, the demo was limited today. But if anyone wants a full detailed, demo, we can book a session. You can get in touch with us. And also, if you'd like to explore how Amantya's AI agents can help your organization modernize, legacy systems faster, we'd be happy to arrange a one-on-one demo or pilot discussion. You can also reach us at connect@amantyatech.com or through the contact details that will be shared along with the webinar recording. Do stay tuned for more updates from Amantya, and we look forward to seeing you in our upcoming sessions. Thank you once again for joining us. Have a good day.